Welcome to the Explainer. Let's dive right in and get this out of the way up front. Prompting an AI is not just casually typing a question into a text box. Not anymore. It is a rigorous form of programming. We are moving way beyond those simple conversational hacks you might see online, and we're entering a realm where we literally treat the AI as a programmable engine. By the time we wrap up here, you are going to see exactly how to manipulate the underlying mechanisms of these models to get precise, predictable, and, honestly, highly advanced results. So, let's get into it.
To really master AI control today, we're going to hit 4 main areas: the science of prompting, the prompt pattern catalog, advanced reasoning and orchestration, and finally, prompting as an empirical science.
All right, part 1, the science of prompting, under the AI hood. So here's a crazy thought. Being overly wordy actively harms your prompt. Why? Because under the hood, these transformer-based AI models use what's called multi-head self-attention mechanisms. Basically, this means every single word or token has to pay attention to every other token. And since the model only has a finite attention budget, if you just pack your prompt with filler words, you get this thing called context dilution. It's kind of like a distracted intern trying to listen to 5 different people talking all at once. Plus, it creates positional bias. The AI heavily favors the very beginning and the very end of your prompt. It's just like us trying to remember a really long grocery list, right? We only really remember the first and last things. So burying your most critical instructions dead in the middle? Yeah, that's a total recipe for failure.
Now, there's this really inherent tension between an AI model's raw, unbridled capability and its conservative behavior. And this comes directly from its 3-step training pipeline. First up, pre-training, where it essentially learns world knowledge, then supervised fine-tuning, where it learns how to actually follow instructions. But it's that 3rd step, RLHF, or reinforcement learning from human feedback, that's supposed to make the model helpful and, safe. The catch? That safety layer often introduces a heavy conservative bias. It makes the model super prone to over-explaining things or sometimes just flat-out refusing to do your tasks. And frankly, effective prompt engineering is all about navigating that exact tension.
So, the absolutely crucial point here is that you can teach the AI completely new behaviors simply by how you structure your text in the moment. No way, right? You literally don't need to retrain the model or update a single parameter weight. This is called in-context learning. When you drop examples straight into your prompt, you're actually activating specific latent spaces inside the model. Essentially, you're waking up relevant clusters of knowledge inside the AI's brain, priming it to recognize patterns and adapt to your specific task right then and there on the fly.
Listen, never ever underestimate the power of highly constrained formatting. Just saying, analyze this data is wildly ambiguous. The model has to guess what you want, and that almost always leads to a frustrating, totally generic output. But when you give it a highly precise task, say performing sentiment analysis, and give it a constrained classification space like positive or negative, and then demand a strict structural format like JSON, you completely eliminate that ambiguity. You essentially force the model into a deterministic lane, and that gets you that incredibly satisfying, exactly what you asked for response.
Okay, moving on to section 2, the prompt pattern catalog, theory into practice. By categorizing these interactions into specific domains, we basically build a mental toolkit of reusable solutions to enforce rules and automate our processes. Think of it like software design patterns, but for AI interaction problems. Whether you need to heavily customize an output, force the AI to identify its own errors, or even radically change how you interact with the model altogether, there's a proven pattern you can deploy for it. I absolutely love this example of the output automator pattern because it literally eliminates tedious manual labor. Instead of having the AI spit out these fragmented snippets of code that you then have to manually copy, paste, create, and save into a dozen different files, you just instruct the AI to generate an automation script alongside its answer. Then you run that one Python script, and boom, it builds the entire file structure for you. It's a massive game changer for your workflow.
Normally, we're the ones interrogating the AI, right? But what happens if the AI actually knows better than we do about what information is required to pull off a complex task? Well, we can use what's called the flipped interaction pattern to create a total inversion of control. We literally put the AI in the driver's seat.
By stating a distinct goal upfront, like deploying a Python application to AWS, the AI will methodically interrogate you until it has the exact constraints it needs to avoid hallucinating. The best part? You don't even need to know all the technical requirements from the jump. The AI is going to ask you about your database needs, then your traffic expectations, your security protocols, all one by one. And once it's finally satisfied, it executes the goal.
You can even combine the persona and gameplay patterns to simulate entirely new, totally unexpected interactive environments. Take this cybersecurity training game, for example. Here, the AI acts as a hacked Linux terminal. So when you type in real terminal commands, the AI synthesizes a completely fake file system and generates realistic log files, leaving digital breadcrumbs for you to investigate. I mean, it is just incredibly cool, and a massive expansion of what we typically think an AI can even do.
All right, let's scale things up in Section 3, Advanced Reasoning and Orchestration.
By forcing the model to explicitly break down its reasoning step by step, we actually allocate more computational power to the problem and drastically reduce errors. We call this chain of thought. Say, because a transformer processes things one token at a time, making it write out its intermediate steps literally gives it more time to think and self-correct. It's kind of like forcing a student to show their math on a test. And then, Tree of Thoughts takes this even further, asking the AI to explore multiple different reasoning paths, evaluate them all, and then select the optimal one.
This explicit reasoning scales up beautifully into the Retrieval Augmented Generation, or RAG architecture, which allows the AI to reference massive external databases. But hey, remember our earlier chat about positional bias? Because of that lost-in-the-middle memory phenomenon, if you inject, say, a dozen long documents into your prompt, the AI might completely ignore the ones right in the middle. So you absolutely must place your most critical context at the very beginning or the very end of the prompt to ensure it actually gets processed.
The most advanced implementations out there are using dynamic prompts that adjust on the fly. It unlocks this true choose-your-own-adventure interaction style that accesses the AI's full feature richness. So instead of just a single static prompt, you're building a network of stages. Say the AI detects high risk in a customer profile. The system dynamically routes it to an aggressive investigation prompt. If it detects low risk, it just branches off to a streamlined summary prompt. It's brilliant!
Which brings us to our final section, Part 4. Prompting as empirical science evaluation.
Systematically evaluating your prompts means you have to leave behind the random guesswork and embrace rigorous empirical science. You need to define clear success metrics, like accuracy or token efficiency. You have to build diverse test sets with weird edge cases. You absolutely must isolate your variables, A/B test prompt variants individually, and implement strict version control, just like you would in software engineering, because this exact framework is what ensures predictable performance across different models.
Never ever give conflicting instructions like, be concise but explain thoroughly. I mean, what does that even mean to a math-based token predictor? Instead, use explicit XML or JSON structural hierarchies to completely eliminate that ambiguity. By wrapping things in XML tags, you create strict, undeniable boundaries for the AI. Models like Claude, they respond incredibly well to XML, while GPT-4 excels with JSON. But both of them absolutely require this level of explicit, structured instruction.
So the big takeaway from all this is that engineering and AI's behavior requires the exact same rigor, iteration, and testing as writing traditional software. We are way past the point of just having fun conversations with a chatbot. We are using structural patterns, deep attention mechanism theory, and empirical A/B testing to build robust, predictable, and highly functional AI pipelines.
And that leaves us with a fascinating thought about the future of human-AI collaboration. With techniques like automatic prompt engineering already emerging, these systems are actually learning to write better prompts for themselves than we can write for them. So if prompting is really just programming and the AI soon becomes the ultimate prompt engineer, what exactly will our role be in guiding the machines of tomorrow? Think about that for a bit and keep experimenting.